Mixture problems are a type of system of equations where we have two unknowns and two relationships. So here we have a mixture of concrete, and concrete has 3 times more gravel than cement. If there's 140 kilograms of concrete, how many kilograms of each? So essentially it looks like this. We have concrete, all that is concrete, and part of it is gravel, and part of it is cement. Okay, so we have 3 times more gravel than cement, so it looks kind of like this. So what we can do is we can let x equal amount of either cement or gravel. So we'll let the x equal the amount of gravel, and then y represents the amount of cement. Okay, so to get the concrete then we're going to mix these two together, and it looks like this. So we're going to have one equation will be 140 kilograms is equal to the amount of gravel plus the amount of cement. So there's one equation. Okay, the other equation, the relationship is going to be I have 3 times more gravel than cement. Okay, so I'm going to do that maybe in different colors here. So this is equation 1 based on the 140 kilograms of concrete. Okay, so 140 is equal to x plus y. And then the second relationship is going to be from here. There are 3 times more gravel than cement. So if I want to make the cement equal to the gravel, I need to do 3 times the cement is equal to gravel. Okay, so we need to make the smaller amount 3 times bigger, and then makes it equal. Once we have this, we can then solve this as a system. I'm going to substitute x in here, so I'm going to take equation 1. So I have 140 is equal to 3y plus y. I did a like for like replacement and solve for y. So y works out to be 140 divided by 4 is 35 kilograms. We have to make sure we solve for x. So if y is 35, then x is going to be 3 times that, which is going to be 105 kilograms. So we can solve it as a system here. We could also solve it as a proportion. So we know that all of this is 140, and we know that we have 3 parts here. We can divide this into 3 parts, so we can divide this into 4 parts, and each part would then be worth 35, so we know we have 105. So we have 35, 35, 35, 35. So we have 105 parts gravel, and we have 35 parts cement. Okay, and that's what that would look like. So here's another problem. We have juice that's made from 90% concentrate and 40% concentrate. And you want to dilute the 90% with the 40% and end up with 2 liters of, so we need to start with 90% and make it into 40% by adding the 20% mixture. So he has 2 liters of 90% juice. How much of the 20% does he need to add? So maybe let's draw this out. So we have, in this case here, we have a 90% mixture, and this is 2 liters. And we need to add in 20%, so x liters of 20%. Okay, and then the result is going to be a bigger amount. So I'm just going to maybe make this a little bit smaller like this. And we need to have a bigger amount of 40%. And this is going to be 2 liters plus x. We have to add some amount to the 2 liters to get the 40%. Okay, so we need to have some unknowns here. So we're going to let X represent the number of liters of 20% juice. Okay, and then we'll let Y equal the total liters of juice. Okay, so those are our two unknowns. And so we know that our first equation is going to look like this. Y is equal to 1 liter, or 2 liters plus the amount that we add. Okay, so that's going to be one relationship. So that we have one equation. We need to come up with a second relationship, and that second relationship is going to be the amount that we have. So we have to come up with another relationship that involves X and Y. So we can say that the total amount of juice is going to be determined by the percentage times the liters. So the total amount of juice, of concentrated juice, is going to be 0.4 times Y plus 0.9. Okay, so that's going to be the total amount. That's going to be comprised of 90% times 2 liters plus 20% times X liters. And so this is going to be the amount of concentrated juice in total. This is amount of concentrated juice in the 2 liters that of 90%, and this is going to be the amount of concentrated juice that we had in the X liters of 20%. So solving this, we're going to, since it's equal to Y, we'll do a substitution for Y. So we end up with 2 plus X is equal to 0.9 times 2. We'll just make that into 1.8. So this is the amount of juice in the 90% plus 0.2x. Okay, and then we can solve this equation for x. So we end up with 0.8 plus 0.4x equals 1.8 plus 0.2x. Subtract 0.2x from both sides. Subtract 0.8 from both sides. When I divide by 2, I get x equals 5 liters. And if x equals 5 liters, y works out to be 7 liters total. Okay, I think the question was asking for how much 20% mixture does he need to add? He needs to add 5 liters. So just to show you where these different parts are, this represents that amount, so that's going to be my 1.8. This represents down here the 40% with the total amount is going to be this amount here, and then this 0.2 liters that the X liters that I add at 20% is the amount that was added in. Okay, so the green plus yellow gives me the blue. So we have to be careful because we can't add percentages because they're ratios, and we can't just say 20 plus 90 and then average it out or something like that. It doesn't quite work that way. So we have to make sure that we are making equations based on here. This is equation based on the volume or liters. This is an equation based on the amount of juice that we had once we multiply the volume times the percentage.